Okay, so computing a percentages for categories of a budget. So the circle graph shows how, okay, let me see. Shows how Trey's family budgets a total of $7,300 for the month. All right, they could have done these amounts, these numbers in percentages, but well, that's okay. But they just did them in straight dollars. So this is how they wrote out their budget. In terms of a pie graph, I just did a spreadsheet with no graphics. Okay, so find the percentage of the total budget. So we're comparing something to the total budget, not to something else, for each category listed below. All right, so let's see what we got here. So for utilities is going to be $949 out of the $7,300 budget. Okay, so 949 divided by 7,300 is going to be 0.13, so 13%. Okay. Then they say, how about transportation? Transportation is $584 out of $7,300. Let's see, 584. And that'll be 0.08, or in other words, 8%. And then you do the same thing for food, 1314 divided by 7,300. Okay. So if we were to find the percents for all of the slices of the pie, what do you think it would add up to? Oh, very good, 100%. Well, this feels like Blue's Clues. I ask a question, give you a second, and then I answer it myself and pretend that you answered it. Oh boy. Okay, so anyway, so that would be, yeah, it would add up to 100%. Now, just to kind of give you a little more information about percents. What if it said, find the percentage of like utilities from, instead of the total budget, what if it was something like out of transportation, insurance, and utilities? So if they said, find the percentage, what percent do we spend on utilities out of transportation, insurance, and utilities? Instead of comparing the 949 to the total budget, we would be comparing that to the portion that they tell us to compare it to, the 584, the 219, and the 949. Boy, that's some terrible penmanship. Okay, which would simplify to 949 over 584 plus 219 plus 949. That's a lot of utilities. Which would only be 1752. They're not going to ask you to do this, but I just want to point this out. So in other words, that would be about 0.54. So that means that utilities is, or I'll circle this one, utilities is 54% of transportation, insurance, and utilities. It's a little over half of those three categories. So I just wanted, hopefully broaden your horizons just a little bit on that. All right, so Alonzo has 2 coupons for a jacket. Oh, that's cool. So $14 rebate on a $77 jacket, or 15% off of a $77 jacket. I hate those rebates because I don't always remember to do them. Yeah. Anyway, okay, so choose the coupon that gives the lower price. All right, so for coupon A, it'll be $77 minus 14. So he pays a total of $63. Okay, let's do a different color. Okay, whereas coupon B says we're going to knock off 15%. So $77 minus 15% of $77. Okay, so let me just type that in. Whoops, not typing correctly. And that gives us Survey says, whoops, let me put that where it actually belongs. There we go. $65.45. So the rebate is a better deal. Yeah. Now, you could have done the second one, coupon B, and just said, well, if we're going to knock off 15%, that means that we're going to pay 85% of the original price. And that would work too. So you could say 100% of the price minus 15% of the price, or you could just say 85% of the price. Either way, I don't care. You do whatever feels good for you. But that is how this kind of problem would be done. Obviously, the stuff in this chapter is quite useful because it's how you make financial decisions for the most part. The Postal Charity received a donation of $18.7 million. That kind of reminds me of, what was it, Ocean's 13, I think. That was, or yeah, Ocean's 13, except it was like 100 million or something. If this represents 48% of the charity's donated funds, what is the total amount of its donated funds? So once again, I'm just going to translate from English to math, okay? The English statement would be $18.7 million is 48% of the donated amount. So I just write that down. 18.7 million is 48% of the donated amount. Oh, hey, I'll get really fancy and say D for donated. Ooh, yeah. So, oh, okay, so all I got to do is divide by 0.48. Hope you guys can see this because, I mean, I'm colorblind, so it looks clear to me, but, you know, whatever. And we get, see, round to the nearest $1 million. So it's 38.958. That's going to round off to $39 million. $39 million. So you would just put a 39 right there. But that's all it is. You know, you just translate from English to math. $18.7 million is 48% of the amount. And then that's all I do. Okay. So, all right. So finding the total cost, including tax or markup. I don't know why my microphone went off. That was freaky. Okay, so the wholesale price for a shirt is $5.50. Okay, so there's a couple of things to be aware of. Wholesale, that's how much the distributor, just for lack of a better expression, that's how much the distributor sells it to the store you're going to buy it at. So the people that make the shirt, they sell it to I was going to say Lowe's, but they don't sell a lot of shirts. TJ Maxx, I don't know. I never go shopping. I don't care about shopping. But they sell it to TJ Maxx, and the price they sell it for is called wholesale. Okay, and then TJ Maxx, they sell it to you for what's called retail. Okay. And you pay the retail price. And often, on my experience, has been retail for clothes is like double what it was here. Okay, because the retailer, like TJ Maxx or Walmart or whatever, they got to pay for this. Okay, so they got to charge wholesale plus more so that they actually make money. But then they got a part of what they charge is going to go toward paying for insurance, paying their employees, paying to keep the lights on, paying for a whole bunch of stuff. So it makes sense that, like, you know, they might double the price. So they actually have something left over for a profit, okay, for the company. Okay, so that's kind of the idea there. Woo. Okay, so the wholesale price for a shirt is $5.50. Certain department store marks up the wholesale price by 90%. Okay, so if you mark it up by 100%, that means you're taking the original amount, original 100%, and adding that back on. In other words, you're doubling it. So when they say 90%, they're not quite doubling the price, but close. Okay. Well, double this would be $11. So the department store is going to sell it for a little less than $11. My guess, is like around 1045 or so. I'll even write that down because, hey, that's my guess. Okay, find the price of the shirt in the department store. Okay, so the price of the shirt in the department store is going to be the original $550 plus 90% of that wholesale price, $550. Or you could just say 190% of $550. Either way, it doesn't make a difference. Whoa, 1045. Man, I'm a really good guesser. Okay. And that's how you do it. Okay. And again, I mean, this is how some basic economics works. So hopefully you're not looking at this just saying, I want to pass the test. Hopefully you're also thinking, I want to know how the world works around me. Okay. Okay, last topic for this video. Combined effect of more than one markup. More than one. Okay, groovy. Well, Frank is a nice guy, and Frank is looking for the best deal on an electric stove. Yeah, I tried gas. I did not care for it. Almost made the kitchen heat like 90 degrees. Of course, we didn't have air conditioning. Frank is looking for the best deal electric stove that has a wholesale price of $679. Okay, so that's what the distributor is selling it to Home Depot for, or wherever you get your stuff. Okay, help him compare the price of the electric stove at two different stores by completing the following. So the wholesaler is going to sell this $679 to like Lowe's and Home Depot. And so we're going to say, all right, what's going on at those two stores? So part A, Frank goes to a superstore that marks up the electric stove's wholesale price 20%. Wow, that's not much. Ignoring tax, how much would he pay for the electric stove at this store? All right, so he's going to pay 120% of the wholesale price. Okay, and in other words, the original 100%. The original $679 plus another 20%, the markup. Okay, or you could just say, I mean, like we've been doing, you could say 679 plus 20% of 679. Either way is fine. Let's see what we got here. So 1.2 times 6. Whoops, I put it wrong. And we get $814.80. Okay. And again, how do I get all these things? Well, like you've been seeing me doing, I just translate from English to math. Okay, he's going to pay the original amount plus 20% of the original amount. That takes practice, but it's totally doable. Okie dokie, Smokey. So Frank then looks at the electric stove in a department store that marks up the electric stove's wholesale price 30%. But because of a customer loyalty program, he would receive a 10% discount off the in-store price. Ignoring tax, how much would he pay? And that's okay to ignore tax on these because, I mean, all you really care about is which one has a higher sales price or a lower sales price. And there are some countries where they don't add tax on afterwards, where taxes, the little tag that says this is the price, tax is already added in. So you already know, which makes a lot more sense to me. But I don't see things changing in that regard around here anytime soon. Okay, so he's going to pay, or so the store is going to charge 130%, so a 30% markup of the $679. Okay. Let's see. So it'll be 1.3 times 679, and that'll be 882.70. And then they say, all right, well, we're going to knock off. We're going to have a 10% discount. Now we're not going to end up with 814.80 because our 10% is not based on 679. Our 10% is based on the in-store price. So we're going to take that in-store price and we're going to subtract 10% of that in-store price. Or in other words, we're just going to keep 90% of the in-store price. Same thing. All right, so did I do it correctly? And it's going to be smaller because we're knocking off 10% of a larger number. So this 10% is bigger than it was in part A. And it's going to be 794.43. Okay. So select the true statement. Frank would pay less for the electric stove at the superstore. Frank would pay less for the electric stove at the department store. Yep. Okay. So yeah, he's going to save about 20 bucks. Okay, about. Hey, why not? Unless of course it's really far away or something. You're like, okay, gas money. Ugh. Okay.